So in this video, we are going to cover trigonometry. This is a common chapter for both CBSE syllabus class 10 and Telangana SSE class 10 mathematics. So in CBSE, the chapter name is Introduction to Trigonometry, while in Telangana SSE, the chapter name is Trigonometry. So we start from trigonometry. Okay, this is the chapter which is common for both CBSE syllabus and 10th class SSE state board. So basically trigonometry, it is a combination of two words. So one is nothing but trigon and second one is nothing but metry. Okay, so the term trigon, okay, so which is nothing but one class of polygons. So what is meant by polygon? So polygon is nothing but it is geometrical shape which is going to have more number of sides. Okay, for example, if it is a square, so it is a polygon with the sides 4. Okay, if it is a hexagon, so it is a polygon with sides 6. So polygon means it is a geometrical shape which is going to have more number of more than 2 sides. So here trigon, so tri means 3. So it is a geometrical shape which is going to have 3 sides. Okay, so that is called as trigon, and metry, it is related to measurement. Okay, so in this chapter we are going to take a geometrical structure. For example, here I am going to draw a geometrical structure. Okay, so this is nothing but a geometrical structure. Basically it is a polygon. Okay, so this is a polygon in which we have side number 1, side number 2, side number 3. So this is a polygon which is going to have 3 sides. So that's why it is called as trigon. Okay, so in which we are going to measure, okay, the length of the sides. Okay, for example, if this trigon is represented as ABC, okay, you can measure the length BC. So you can measure the length BC, or you can measure the length AC. So this is nothing but AC, or you can measure the length AB. Okay, so you can measure the length. Okay, so this is nothing but length. At the same time, you can measure the angles between these sides. Okay, so that is nothing but, for example, angle A, angle B, angle C. Okay, so these are the 3 angles which you can measure. So that is related to metry. So metry is nothing but it is related to a mechanism in which you are going to measure. So in this class we are going to measure the length of trigon, the angles of trigon. Okay, that's why this is called as trigonometry. So in this chapter most of the time we are going to make the use of right angled triangle. Okay, so right angled triangle. So what is meant by right angled triangle? So already told you, triangle means it is a polygon. So this is nothing but a polygon. Okay, polygon means it is a geometrical structure which is going to have more number of sides. But whereas in case of triangle, so tri means it is a 3, therefore it is a polygon with the 3 sides only. Okay, so for example, here I am going to represent this trigon as ABC. Okay, so what is meant by a right angled triangle? Okay, so right angled triangle means, okay, it is a triangle. Basically it is a triangle, nothing but it is going to have 3 sides. Okay, in which 2 sides are perpendicular. Okay, so there are 2 sides in which 2 sides are perpendicular to each other. Okay, perpendicular means both the sides are going to be making some angle. This angle should be 90 degrees. So that is called as a right angle triangle. For example, you can see on the board. Okay, so here the sides. So what are the sides? Okay, So side A and C, nothing but AC. So this is nothing but AC side, and another side is BC. Okay. So these are the two sides which are perpendicular to each other. Okay. So such type of a polygon with the three sides, in which two sides are making 90 degrees with respect to each other. So that is called as a right angle triangle. So this is nothing but a right angle triangle. So in which we have to identify the sides. Okay. So sides of right angle triangle. Okay. Sides of a right angle triangle. So basically it is a polygon with three sides. So we have to identify the three sides and we have to assign a particular name to those three sides. Okay. So first of all, to identify the sides, so we have to define the sides with respect to a particular angle. Okay. So here I am going to take the angle. So here this is nothing but the theta. Okay. So sides are, for example, identified with respect to an angle theta. Okay. So here the angle you can take at B, the angle you can take at A. Okay. So in this example I am going to define the three sides of the triangle with respect to this particular angle which is located at the corner B. Okay. So first of all, we will define what is meant by hypotenuse. So we will define the first side which is called as hypotenuse. Okay. So what is meant by hypotenuse? Which is the side called as hypotenuse? So from the diagram, the hypotenuse is nothing but a side opposite to 90 degrees. Okay. The side which is exactly opposite to 90 degrees because it is a right angle triangle. So one of the angles should be 90 degrees. Okay. So the side which is exactly opposite to 90 degrees, that is called as hypotenuse. So here I am going to represent that hypotenuse as H. So from the diagram you can see, so triangle, right angled triangle means it is a polygon. Okay, triangle means it is a polygon in which the structure is going to have three sides. Okay, so right angled means it is a polygon in which the two sides are perpendicular to each other. So AC and BC, these are perpendicular to each other. Okay, therefore 90 degrees. Okay, so as per the definition, hypotenuse means the side which is exactly opposite to 90 degrees. So this is nothing but, okay, the side which is exactly opposite to 90 degrees, that is called as hypotenuse. So in our diagram, the side hypotenuse is nothing but AB. Okay. So here the side AB is called as hypotenuse. Okay. Then we will define another side. Okay. So opposite side. Okay. So opposite side, the second side of a triangle, so that is called as opposite side. Okay. Okay. The side opposite to the reference. Okay. The reference angle. So I am going to define all the three sides with respect to the angle at B, that is nothing but theta. So with respect to theta I am going to define hypotenuse. With respect to theta I am going to define opposite side. So as per the definition of opposite side, the side opposite to the reference angle. So here this is nothing but the reference angle. Okay, the side which is opposite to reference angle, that is nothing but AC. Okay, so this AC is called as opposite side. So in our case, the side AC. Okay, the side AC, because this is the side which is exactly opposite to theta. Okay, So that is called as opposite side. So this is nothing but opposite side, the second side. Then moving to the third side. Okay, the third side, because it is a triangle, it is going to have only three sides. So one is nothing but hypotenuse, exactly opposite to 90 degrees. Okay, then next side is nothing but opposite side, which is exactly opposite to theta. Okay, then the last one, the third side, that is called as adjacent. Okay, so adjacent, capital A. So the third side. Okay, so the definition of adjacent is nothing but the side of the triangle. Okay, the adjacent side. Adjacent side of the reference angle. Okay, the side which is adjacent to theta. Okay, the reference angle here theta, because I am defining all the sides with respect to this particular angle. Okay, so the adjacent side to theta, that is called as adjacent. Okay, so theta adjacent angle is nothing but, you can take this one or this one. Adjacent is by nothing but nearby, base like. Okay, so, but already we have taken this one as hypotenuse. Therefore, the adjacent of theta is nothing but this side, which is nothing but base of the triangle. Okay, so the adjacent in our case, it is BC. Okay, so this is nothing but the adjacent. Okay, this is nothing but opposite side, and this is nothing but hypotenuse. Okay, so what is meant by right angle triangle? So it is a polygon with three sides, in which two sides are perpendicular to each other. So those are the sides AC and BC. These are the two sides which are making 90 degrees with respect to each other, nothing but perpendicular to each other. Okay, so this type of trigon is called as right angled triangle, in which, okay, the opposite side of theta, okay, the opposite side of theta is called as opposite. Okay, the opposite side of 90 degrees is called as hypotenuse. Okay, the adjacent side of theta is called as adjacent. Okay, so this is with respect to the angle which is located at B. Okay, so similarly here also I am going to define all the three sides, nothing but I am going to identify the three sides. Okay, so again, right angled triangle, same triangle ABC. Okay, two sides are perpendicular to each other. So I am going to define the three sides with respect to this theta. Okay, where theta is at A. So with respect to A, I am going to define the three sides. So as per the definition, the hypotenuse is nothing but the opposite side of this 90 degrees. Okay, so this is nothing but hypotenuse. Okay, then opposite side. So opposite side is nothing but the side which is exactly opposite to the reference angle. So this is nothing but opposite side. Okay. Similarly, adjacent side is nothing but it is the adjacent side of the triangle with respect to theta. So this is nothing but the adjacent side. Okay. So nothing but with respect to theta, you are going to identify all the three sides. So this is about the right angled triangle. So one more point. So from this figure, basically the total angle, the sum of all the three angles in a triangle is nothing but 180 degrees. Therefore, capital A, nothing but angle at capital A, angle at capital B, and angle of capital C should be equal to 90 degrees. So this is nothing but the general case of any triangle. Okay, but in case of right angled triangle, one angle is 90 degrees. So in this example, the angle at point number C is 90 degrees. Therefore, capital A plus capital B plus angle at degree C, angle at C is nothing but 180. Because one angle in case of a right angle triangle is 90 degrees. Or the sum of remaining two angles becomes equals to 90 degrees. because angle A plus angle B equal to 180 minus 90. Therefore, the remaining 90 degrees will be shared by the remaining angles. Okay. So this is nothing but one point in case of the right angled triangle. Okay. Then you can see from the diagram. So the side which is going to have longest length. So that is nothing but hypotenuse. Okay. So the longest side. So the longest side is nothing but hypotenuse. Okay. So this is the longest side of the right angled triangle. Okay. At the same time, sometimes it is useful to make the use of Pythagoras theorem. Okay. So according to this Pythagorean theorem, you can write hypotenuse square equal to opposite side square plus adjacent square. So from the diagram, the hypotenuse is represented as AB. Okay. Therefore, AB square equal to, okay, opposite side is nothing but AC square plus, okay, adjacent is nothing but BC square. Okay, this is another relation. We have to make the use of this relation most commonly in this chapter. So that is according to Pythagorean theorem. So the square of hypotenuse is equals to the sum of squares of opposite side and adjacent. Okay. So this is nothing but the second point. Trigonometric ratios. So in this class we will define the trigonometric ratios, particularly in a right angled triangle. Okay. So here I am going to draw a common shape. So this is nothing but a right angled triangle. So what is meant by right angled triangle? So it is a polygon with the three sides. Okay. So three sides, AB which is one side. Okay. BC, this is nothing but second side, and AC, this is nothing but third side. So polygon is nothing but, triangle is nothing but, it is a polygon in which we have only three sides. Okay, that is called as a triangle. But what is meant by right angled triangle? Okay, so it is a triangle in which two sides, AC and BC, two sides are perpendicular to each other. So that is called as right angled triangle. Okay, so this is nothing but a right angled triangle ABC, in which we have 90 degrees at point number C. Okay, then we have to identify the sides of a triangle. Okay, as per the definition of hypotenuse, the opposite side of 90 degrees. So this is nothing but, okay, hypotenuse. I am going to represent this one as H. Okay, hypotenuse. Then, so I am going to define all the sides with respect to a particular angle. The particular angle theta is located at B. Okay, so with respect to B, the opposite side. The definition of opposite side is nothing but the opposite side of this theta angle, reference angle. So that is nothing but AC. So this is called as opposite side. Okay. So we have hypotenuse and opposite side. Then another side we have to identify, that is called as adjacent. Okay. So what is meant by adjacent? So with respect to this reference angle theta, okay, the adjacent side. Okay, the adjacent side may be this one, the adjacent side may be this one. But already we have labeled this one as hypotenuse, therefore the adjacent side of theta is nothing but this BC. So I am going to represent this one as BC. Okay, so we have constructed a right angle triangle in which we have already identified the hypotenuse, opposite side and adjacent. Okay, now we will define the trigonometric ratios. Okay, so the first trigonometric ratio, that is called as sine theta. Okay, the trigonometric side sine nothing but the trigonometric ratio sine theta, which is defined as the ratio of, okay, opposite side divided by hypotenuse. Okay, so sine, the ratio, trigonometric ratio sine theta is nothing but it is the ratio of opposite side and hypotenuse of a right angle triangle. So in our diagram you can see the opposite side is nothing but AC. Therefore AC divided by, okay, hypotenuse is nothing but the side which is opposite to 90 degrees, that is nothing but AB. Okay. Similarly, the second trigonometric ratio, that is called as cos theta. Okay. So it is defined as the ratio of adjacent side to hypotenuse. Okay. So from the diagram, the adjacent is nothing but BC. So again hypotenuse is nothing but AB. Okay. So similarly, the third trigonometric ratio, so that is called as tan theta. Okay. So tan theta is nothing but the ratio opposite side divided by adjacent. Okay. So opposite side means theta. For theta, opposite side is nothing but AC divided by the adjacent side is nothing but BC. So these are nothing but the three common trigonometric ratio, and we have furthermore three trigonometric ratio. So which is, okay, cosec theta. Okay. So it is very simple to define. It is nothing but the reciprocal ratio of sine, nothing but opposite side divided by, hypotenuse divided by opposite side. Okay. So that is nothing but AB by AC. Similarly, we have secant, nothing but sec theta. So which is nothing but the reciprocal ratio of cos, nothing but hypotenuse divided by, okay, adjacent. So you can write this one as AB by BC. Okay. Similarly, we have this is nothing but fourth one, fifth one, and the sixth one. Okay. So sixth ratio is nothing but cot theta. Okay. So which is nothing but the reciprocal ratio for tan. So that is nothing but adjacent divided by opposite side. Okay. So that is nothing but BC divided by AC. Okay. So these are the three trigonometric ratio in case of a right angle triangle. Okay. So you have to remember the definition of all the trigonometric ratio. Okay. But here I will give you a trick to remember these ratios, nothing but to define these ratios. Okay. So the sentence, the quotation is nothing but overcome all obligations. Okay. So during the journey of life you may be having or you may be facing different problems, so you have to overcome all these issues. So that is the meaning of this sentence, overcome all obligations. Okay. Hold, nothing but keep, hopes alive. So keep all your hopes alike. So this is nothing but the two statements. So by using these two quotations, we are going to define the trigonometric ratio. Okay. So first of all, I am going to define the sine theta. Okay. So sine theta, here you can see this is nothing but O, this is nothing but H. So O means opposite side. Therefore, sine theta is nothing but opposite side, okay, divided by hypotenuse. So this is nothing but first ratio. Then you can see this is nothing but A and here H. Okay. So moving to the next trigonometric ratio cos, okay, that is nothing but A, nothing but adjacent divided by hypotenuse. Okay. So this is nothing but the second trigonometric ratio. And the third trigonometric ratio tan theta. So here O again A, nothing but the ratio opposite side divided by adjacent. Okay. So by using these two quotations, you can define the three trigonometric ratios. Okay. If you are able to identify these three trigonometric ratios, then you can easily write the definition of remaining three. So that is nothing but cosec theta equal to, it is nothing but the reciprocals. Okay. So nothing but hypotenuse divided by opposite side, which is nothing but the reciprocal of sine. Okay. Next ratio is nothing but secant theta, nothing but sec theta. So sec theta is nothing but the reciprocal of cos. Okay. Nothing but hypotenuse divided by adjacent. Okay. The sixth one, that is cot theta. So which is nothing but the reciprocal of tan theta. Okay. Nothing but the ratio of adjacent to opposite side. Okay. So this is nothing but one hint to define or to remember that all the six trigonometric ratio overcome all obligations. Nothing but you have to face all the problems. Then hold hopes alive. You have to keep your hopes alive. Don't leave them. So these are the two quotations. Okay. By using these two quotations, you can define all the six trigonometric ratio. So in the next video class, we will do some problem depending on these definitions. Okay.